Okay, this is problem 32 from chapter 4. 432. Here there's a figure given, which I'll draw in a second. A window washer pulls herself upward using the bucket pulley apparatus shown in the figure. How hard must she pull downward to raise herself slowly at constant speed? And then if she increases this force by 15%, what will her acceleration be? The mass of the person plus the bucket is 72 kilograms. So we have a pulley system, a fixed pulley. Over this goes a rope, and this rope is connected to a bucket. Inside this bucket there's a person who also pulls this one. Okay? And the mass here is given to be 72 kilograms. This is the mass of the person plus the bucket. Now how would you approach this problem? So first of all, can this be done? I mean, we know that normally you can't just, pull yourself up, but if you have something to hold on to, you can. And in this case, there is something you can hold on to. In the worst case, you could just pull the pulley, but pulling a rope that goes over the pulley is more efficient. As you'll see, this actually saves you some time. Now, this can be done. Okay? So there's no basic physical principle why this can't be done. So let's start trying to solve this problem. Where will we start? We start by drawing the free body diagram. Okay? So I'm going to be drawing the free body diagram for the person bucket system. So of mass 72 kilograms, there's no point in dividing this into any further. So what are the forces acting on this system? First of all, there's gravity, it's always there. Okay. This in fact is going to be this mass times g, so it's 72 times 9.8 newtons. There's going to be some tension force coming from this rope that's connected to the bucket. Okay, it's pulling us up. Remember that when your rope is tight, there's always going to be a tension force. That tension force is going to be away from the object. Right? So there's going to be some Ft. Now what else? Now this person, first of all, why is this tension happening? Why is the rope tight? Because this person is pulling down the rope. Well, if you pull down the rope is going to pull you up. That's action and reaction. So there's going to be another tension force acting from here. Okay? So this is going to double up the same tension force in the same direction, being applied twice. Okay? Once from the point where the rope is connected to the bucket, and once from the hands of the person that's just pulling. It's also, you can say it's connected to the bucket person system in some way. These are going to be the same because our ropes are, masters are pulleys are frictionless and so on and so forth, but they're both going to be up. Now the force we apply to the rope is down, but that doesn't concern us. That's not one of the forces being applied on the system, bucket person system. It's a force by the system. It doesn't go into the free body diagram. The only things that go to the free body diagram are the forces on the system. And that's gravity, tension coming from this point, tension coming from this point. Okay? And for part A, the acceleration is 0, which means the net force is also 0. And well, the only way for net force to be 0 is, of course, for these, to cancel. These are the same, so 2Ft is equal to Fg. So tension is m times g divided by 2. So 72 times 9.8 divided by 2, whatever that is, it's going to come out in newtons if you use the correct units. Okay. Now, they're saying if she increases this force by 15%, so for part B, the force that we apply, and consequently the force applied on us by the rope, increases by 15%. Let's call this Ft prime. This is 1.15 times Ft, which is this thing over here. Okay? What will be our acceleration? Now, these guys, let's just throw some Ft primes here, slightly larger. Ft prime. They are now going to overcome gravity. So we're going to have some acceleration, and in fact they're asking us what this acceleration is. So the total force on the system, if we choose up as positive, we have to choose some direction as positive, is going to be F net twice Ft prime, positive because I chose up as positive, minus Fg. And I can easily write this. This is 1.15 times this times 2. Okay, 2 times 2. This is just 1.15 mg. 2's cancel, we end up with 1.15 mg minus mg. This is just 0.15 mg, and this is equal to m times a, as it should be by Newton's second law, F equals ma. M's are going to cancel. The acceleration is going to be 15% of g, or 0.15 times 9.8 meters per second square.